Hello everyone, welcome back. In today's lesson, we're going to talk about library functions. So for the library functions, there are a few things that we need to know before we dive into the lessons. So there are some already defined functions and libraries in C++ that can help us to do some mathematical operations. And there are some reserved strings and let's say strings for performing these mathematical operations. So when we mention that there are some reserved strings for these things, it means that we cannot use these reserved ones to name our integer, to name our own newly defined string, etc. But now I will give you more information so you will get to know that. But before we go for the library functions, we go up to the code in the beginning of our code. Here, because I want to use these libraries and I want to use the already defined library functions of C++, I need to include it in the C++ program in the beginning. So don't forget to include CMath before we dive into these lesson. So in order to proceed here, we wanna show some already defined library functions in C++. So we define, as before, we define two integer values like x and y. The equals 25 and y equals 4. And as we are not using them, they are like having the warning in the code now. In order to print them, we use the syntax of cout. We know it very well now. And in the end, we put the end L to make sure that it goes to the next line for the following codes. But what are the reserved functions? The first one is sqrt. The sqrt function gives us the a square value of a number, of an integer. So when we define an integer here like x equals 25, and when we want to uh, have the square root of the x, we can simply write sqrt, and within brackets we put the number. So easily it will print us the square bracket of the integer x. So let's compile and see. So now no errors. Exactly. So the square root of 5, a square root of 5. So what we had there was something like a square root of x is 5. So the better typing would be the square root of uh, x, and then we put is the rest of the code. So this can give us a better output and more clear output. So let's check it out again. Let's try this. Yeah. So the square root of 25 is 5. So this is what it is now printing for us. So the first library function is the sqrt. The second one is that when we want to do some mathematical formulation or have some countings in our code, simply we can, for example, instead of doing the math ourselves, like 4 times 4 equals 16, we can define 4 as to be an integer named y, and the power and y to the power of 2 would be like this: po bracket y comma 2. So this code will help us to have the result of the y to the power of 2. Why we are using this? Let's see the print and then I will explain. So it says that power y2 is 16. So here I say power y. So let's say y to the power of 2 equals 16. So why do we need this formula? This formula would be helpful when we have a lot of computation that we need to do. It's easier to automatic everything in the code rather than dive into the details. So it's easier to let the machine do the formula, do the math part for you, and just you use the formulation so you can easily make sure that everything is handled correctly and very well. So the next one is that we define a new integer value, integer variable. We call it val, and the number that is assigned to it is -5. Then, in order to have the absolute value of x, we simply can use this formula abs. Within the bracket, we put the name of the uh, integer variable that we defined. So let's compile and see what the result would be. We have no errors, it's compiling. Okay, now the absolute value is 5. You see, here we assigned -5 and the absolute value is 5. So it is giving us the absolute value. It's a very straightforward library function that we can use in our code while we're doing the formulations. So the next one is we define a double called num and we assign the number 4.3. And so in order to have the rounding up a number to an integer, the nearest integer to it, like rounding up to the nearest integer, would be using the cell function. So we say cell within the bracket num, it will give us the output of 5. So the output of 5 is expected to be seen here. Let's try and see what would happen. Yes, so here we see that the ceiling value is 5. So the value, the original number was 4.3, but the ceiling value is 5. It is rounding up to the nearest integer. Again, we can do this for like the other way. The other way around would be to round down a number. So to round down a number, we define another double called num2 and we assign the value of 4.7 and instead we use the floor function. So instead we would use the floor function and this time we are expecting to see the output as to be 4. Now compiling, no errors. Yes, the floor value equals 4. Let's check it out again here. Sorry. Let's check it out again here. Yeah, so the original number was 4.7 and the printed number is 4. So it rounded down the double number. So another function that would be very helpful for us in C++ would be the following. So if we have two numbers and we want to make sure what the result of what the larger number is among these two. So it's sometimes you might say that, okay, so if we know two numbers like 2 and 7, we already know that the larger number is 7. Yes, this is straightforward. However, in the day-to-day coding, you may define two integer values in the beginning of your code, like let's call them x and y. Then you do a lot of computation on these two values. And since the machine is handling all the computation, you don't know that x would be larger or y would be larger after like 100 lines of code being done for the calculation. And in the end, you just care about the larger number. So instead of, reading all those lines and going through the details, etc., you can simply use this library function. So in the end, you can simply just find fmax, the integer value for the first integer value, and comma the second integer value like here, and then it will just give you the largest value. So here we use fmax and there are two values, 3.7, 3.5 and 7.2, and obviously the larger is 7.2, so you can easily get the larger number here. So this is the maximum 7.2. As I mentioned, it may be straightforward, but when you automate everything in the code, like in tens of lines of code, in the end, you don't need to go through the details. You just simply use this function and it will return you the larger number.